Perfect. Thanks. Okay. So just a little bit about me. My name is Paul Murphy, obviously. My background is a server-side Java developer, native Android development, and JavaScript. And most recently, worked on native Android apps for Vodafone and MTN. I have a master's in multimedia technology, which I did a long time ago. And kind of a lot of things that I did about 12 years ago have kind of come back again with the advent of WebGL and GPUs going into the being accessed from the browser. So with the talk, I'll give a brief discussion of WebGL and Three.js. I'll go through some Three.js tools. I'll describe the core concepts and APIs in Three.js. I'll give a kind of a short, very simple code demonstration just to go through, just so that people can get an idea of it. It's not going to be anything amazing. And then some conclusions, and I'll just take questions afterwards. OK, so what is WebGL? WebGL, it's a web standard for low-level JavaScript 3D graphics. It's for rendering interactive 3D, 2D graphics in a web browser without the need of a third-party plugin. WebGL programs consist of control code written in JavaScript and shader code that is executed on a computer's GPU. WebGL is based on OpenGL, and that obviously has its roots in OpenGL, which goes back 15, 16 years now. And WebGL is just in the process of being widely adopted onto desktop and mobile. The key thing about WebGL is that it is a JavaScript API and you can program with it, but it's quite low level. So if you actually want to do anything that's kind of productive, it is possible, but generally it runs into lots and lots of lines of code and lots of development just to get just simple things on screen. The people who generally program in WebGL would be people who would be developing game engines, that type of thing. OK. So WebGL, it's recently beginning to be more adopted. It came out in 2011. So it kind of hit the Firefox desktop and Chrome desktop browsers first. Then started hitting Safari, and just recently, well, I suppose recently and in the future, it's going to start hitting iOS, especially iOS 8, which was kind of a blocker to a lot of development with WebGL because it just wouldn't run on it. So the great advantage is that you can do 3D graphics on the iPad and on iOS without having any plugins or anything like that. So I suppose it's worth saying that the latest version of Internet Explorer 11, supports WebGL, Firefox, Chrome, Safari, Opera, iOS Safari in 8, and Chrome on Android supports it. However, at the moment, it's not supported in the kind of default browser, and it'll actually be a problem with Android for a few years before there'll be proper support with it. Just the way that the rollout of versions are very slow across Android. So what is Three.js? Three.js is a high-level JavaScript API that's built on top of WebGL, and it makes it much easier to create 3D scenes and animate them. It obviously uses the lower-level WebGL API. It makes it easy to create 3D scenes, which are interactive and animated, and which run the browser using JavaScript. The code is hosted on GitHub, and it has an MIT license. And it's actually quite nice code. It's quite readable, and you can just see where it's calling down into WebGL, and it's saving you hundreds of lines of code. This would be the typical Three.js app stack. You'd have a 3D web app. That could be just a HTML page with JavaScript tag in it. You could call it a glorified 3D web app. It uses the Three.js API library that talks to WebGL API, obviously JavaScript, runs in the browser, running on the operating system, and is taking advantage of the hardware GPU. They're fantastic Three.js demos on the web. I'm not connected up here at the moment, so I'll just refer to where they are. The ThreeJS.org site has some fantastic examples. The type of things that have been done so far have been there've been a lot of marketing companies, I suppose, with big budgets that want to kind of advertise a product. I think there's Nestle have one up there for some green tea, and that's what is kind of being used at the moment for kind of promotional. There was a big Three.js a app created for the launch of The Hobbit, so that's kind of where it is at the moment. In that it's very much kind of marketing, kind of cutting edge web advertising, I suppose, is where it's being used. Obviously, it's also being used in games. I'll talk about it later, but that's expected to increase in the future with a game engine tool called Unity, which is soon enough going to be able to export WebGL. So it's going to make it easy for an awful lot of developers who've already developed all their games in Unity to export it straight into the browser. I'll talk about that a little later. I've just taken some Three.js demos that are running offline, so not as impressive as the ones that are running online. So I'll just show you some of those running in Firefox. So this is these are actually taken just from the Three.js code examples, not the actual front page examples, but it just shows just a very simple example of customizing kind of a prototype of how you'd actually go and customize maybe a product or something like that. I don't know how well you can see it there, but it's the materials on the car and the background that are all quite rendered well. Let's launch this one here. Okay, that's another kind of a relatively impressive example of WebGL, just rendering quite realistic 3D face. And this is just some simple examples of some animation taken from Blender. So I suppose what's great is that you can have this type of 3D graphics without any plugins running on the browser. Okay. Okay, so I just want to talk about just some of the tools that kind of help you when you're using Three.js. Obviously, you can just use a text editor and any regular JavaScript IDE, like WebStorm or something like that, to create a scene. Three.js also has some useful prototyping tools. There's a tool called ThreeJS Editor, and that's very, very useful for actually visually planning out how you're going to construct the scene. When you're kind of faced sometimes with a text editor, it's very difficult to see how that's going to look in a 3D space. There's also 3D modeling software. The most popular, I suppose, for non-game studios would be something like Blender, which is open source and free. There are other 3D modeling software that's obviously quite expensive, and that's used in production movies and AAA kind of level games, but Blender is what's usually used. And then there's game engines, which not quite a Three.js tool, but which is the next version is going to export WebGL. Okay. So this is Three.js Editor. It's very simple, but what's nice about it is that it maps very, very closely to the API and to the code. So whatever you do in this editor, this is running in obviously in a browser. It's structured very, very closely, so you can. It's very, very useful for when you're coding a 3D Three.js scene. This is Blender. There's a plugin that comes with Three.js that you can put into Blender, and you can design much more complicated models. It's far superior than what you can do in a text editor. You've proper design modeling tools. Blender's been around for a very long time. The tools are excellent. So what you can do that, you can model your character, you can texture the model, you can animate the model, and just the fantastic tools. And then you can export that, and there's it will export to Three.js, which you can then use one of the Three.js loaders to load in and populate in the scene. So for things apart from just probably demos or just learning, generally this is what you'd use to get models in. You wouldn't use the kind of the API geometry calls to try and construct a 3D scene. And as I said, Unity 5 will have WebGL Export. The interesting thing about it is it's quite expensive. It's about 1,500 euros per year. So I suppose if you have a business case for it, this might be this might be a better option in that the Unity engine, and the tools that provide are excellent. It's you can produce a game extremely quickly with these tools. And it's also cross-platform. It can do native Android, native iOS, and desktop as well. The desktop, it has a plugin at the moment for browsers, and this is the advantage. But I suppose the main disadvantage of that is that if you have a game up on the web, someone's going to have to go and install the Unity plugin, and that's always a big disincentive. And if you're on the iPad, they're not going to be able to install it on that. So that's why it's big one. So if you're deploying on mobile, I just want to talk about how that would look. With the upcoming iOS 8, there'll be two options. The one on the left is where you would just you could just write your web app and host it online and just run it in the Safari browser. What that allows, in a way, one of the nice things about that is that you could produce a game that's runnable on the iPad, and you don't have to put it into the App Store, and so you don't have to go through the rigmarole of what's involved in that, and it's kind of more freedom as well. The other option is to use Apache Cordova to actually wrap up the web app that you've created using Three.js. The WebView that will be in iOS 8 will support WebGL as well. So that's another option. It's kind of interesting. At the same time, Apple have added 3D to their scene kit. So that's if you were targeting that platform, there's kind of a third option, which is and it's a native option, and that would be the tooling, and that would be very, very good and probably superior to doing it in Three.js. So I suppose it depends on your kind of background. Just related to WebGL and Three.js, I just want to mention WebViewer. This is a kind of an emerging standard. It's very experimental. It was just released into the nightly builds of Firefox and Chrome just last week, and essentially it has integrations for head-mounted displays like the Oculus Rift and Google Cardboard. The interesting thing, the Oculus Rift, I got a developer kit last year for that, and it costs $300. And the Google Cardboard is actually meant to do the same thing with a smartphone, just with cardboard. Facebook has recently, I think they paid about $3 billion to buy the company for Oculus Rift. So there's kind of a bit of, at the Google I/O conference, there's a kind of bit of tongue-in-cheek in that they were saying, you can make the thing with cardboard if you wanted to, with a smartphone. And what's interesting is that the demos that they've actually used for WebViewer are actually implemented in Three.js. Okay. So just in this section, I'll just go through some of the, just simply a very, very high level, just some of the core concepts of Three.js. The core kind of classes or the core objects when you're constructing a 3D scene in Three.js is the scene meshes, which are kind of essentially the objects that you're going to have in the 3D world. Meshes are generally made up of geometries and materials. Geometries being kind of shapes, materials being how the actual object is going to react to essentially light in light conditions. In a scene in Three.js, it's hierarchical, so you can nest objects and you can group objects just like you can in the real world. So if you were designing, a human 3D model, you could set the torso being at the root. You could have the arms then being attached, and you can have that kind of hierarchy that you see in the natural world, and then program on constraints and animation onto those. What you're seeing with your objects that are in there, they're positioned in obviously 3D space. The next thing you want to do is to be able to see them. With the materials that you put on the objects, you position lights as well in your 3D scene to light it up. The regular theory behind, which applies to video production and movies and backfills and doing that type of thing with lights, also apply in a 3D scene. So that type of knowledge is helpful. And then cameras actually for navigating around and displaying different aspects of the 3D scene. The renderer is what happens when you take the scene in the camera. You can have multiple scenes and multiple cameras attached to a render, and the renderer in Three.js is ultimately attached to the browser, to an element in the browser. Okay, so I'll just quickly go through some of just show what the documentation for the API looks like. So obviously the most important thing is creating scenes. There's documentation on the cameras, orthographic camera, perspective cameras. Perspective cameras are the kind of default cameras that are used. Orthographic give that kind of SimCity, that old SimCity type look where everything is kind of rendered at the same size, regardless of how deep it is in the scene. Lights, you have a choice of lights in Three.js. You have ambient lights, directional lights, hemisphere lights, point lights, spotlights for lighting up your scene. The materials, you have some basic materials that just put on a kind of a blunt color onto the object that you're displaying. You also have shaders like the Phong and the Lambert materials, which kind of give either a shiny glow to an object or a kind of a dull look of an object. It provides you with renderers, the WebGL renderer. There are kind of some legacy renderers that it can still render a scene using the canvas, but the actual graphical output is far inferior to what WebGL renders. There's classes for doing animation, for doing curves, kind of lower level curves and lines. And then there's a large library of basic geometries that you can work with as well. Okay, so I'll just give a look at the documentation for say the mesh Phong material. So this is just the format that's creating any of these objects, and you have the parameters, kind of standard JavaScript stuff. I suppose it's worth mentioning, it's pretty obvious that if you are programming this, you're obviously not using any document object model. There's no DOM in this, so libraries like jQuery aren't going to help you out. Certain sections of jQuery aren't going to help you out in this. But other JavaScript libraries would be very useful, like underscore would be very useful. Those type of libraries, we're using it with Three.js, kind of support libraries. You can also use things like AngularJS and whatever libraries you want. Okay. So now just do a small code demo. So it's just going to be simply, I'm just going to build up a kind of a simple scene of boxes, basically, just very, very, very simple. So I'll just start hitting that. So this is about the minimalist scene that you can have, that is to see anything in Three.js. I'll just see if I can navigate over here. Okay. So this is just a JavaScript embedded in a script tag in a regular HTML page, except that there's not much HTML there. You're just basically going to attach it onto the body tag essentially, and render through that. So apart from that, you are in the realm of just programming it up in JavaScript. There's no declarative way of describing a scene. Funny enough, though, way back in 1997 and 98 and 99, there was a language called VRML, which was a declarative way of describing a 3D scene. And it's quite interesting, is that a lot of people are reinventing that again on top of WebGL and Three.js, which is quite interesting. So, so the classes that I previously mentioned, I'll just briefly show how they all kind of link in together. So we have a camera, a scene, and a renderer. They're kind of like the minimal objects that you need. I'm also going to create a mesh. I'm just going to call it red box. There are kind of two important life cycles in a Three.js app: the kind of initialization, where you set up the scene, and then the animation cycle, which actually is transforming that scene and animating it, and where you'd actually be doing any processing, and you can expand to do collision detection, and start writing and taking input and modifying the actual meshes based on the input. So to create a renderer, it's just simply new Three WebGL renderer. You set the size of the renderer, which is generally the width and the height of the browser window, and you attach the renderer to the body of the body element of the HTML document. You can also attach it. You can also this would be for more or less a full screen browser, for taking up the full browser screen window. You can also do things where you can just attach it to other elements. But okay. So you set up a perspective camera. That's just the camera on your scene. You create your scene. You create your box geometries, which is simple box geometry, giving it a width, height, dimension. You create a basic material. This is just simple material, which will put it on red, and you construct a mesh out of the geometry and the material, and with that mesh, you add it to the scene, and then it's ready to be rendered. What will actually do the rendering then is this function down here, which runs in an animate function. It takes the scene and the camera and renders it on the WebGL surface. And there's also a call here to request animation frame. That's suboptimal there at the moment. It'll just run on however fast the actual the machine is, and that will keep on animating. So that looks very, very simple. Just there, it's just simply red cube. So we can just expand it by adding on some other objects. Here I'm just adding on three more meshes. I'm just offsetting their positions. So I will just show what that looks like. These are being rendered, which is a very, very basic material. It's as you can see, it's very difficult to actually see the kind of the dimensions and the depth of the objects. Okay. So next thing is just getting the objects actually animating, and this is a very simple animation which I'm adding in. So it's just in the animate function. I'm just calling the meshes, and I'm just doing .rotation.x plus 0.005 the X, Y, and Z. So you can see that they're kind of animating slowly around. That's kind of the simplest type of animation that you can do. Okay. With this, I'm trying to, with this example here, I'm just trying to improve on the material that's being used. So I'm using a mesh font material, which is kind of gives a shiny appearance to an object, and I'm also adding in an actual light. So the interesting thing is if I don't actually I haven't put any lights into the scene. If I didn't put any light in and put on this type of material, you just see a black screen. So the other material is just simply kind of for debugging, and essentially is that you can just bluntly see where the actual object without having any lights in the scene. So I'll just show what that looks like. So you can see that, I don't know, can you see it, but the actual shading of it has improved, and you can kind of see, you can make the depth out much better. Okay, just here I'm just going to show adding an actual texture onto these boxes. So there's an image utilities library, which I'm just accessing a GIF, and it's just out of Photoshop. It's just a GIF of a crate texture, and I'm just creating a basic material out of that texture on this line here, and obviously it's getting attached to the tree objects. So I'll just quickly go and show that. So you have kind of tree crates just animating around slowly. And just one more thing, just kind of one more basic thing, and it just has to do with the resizing of the window. If with the current version there that I'm showing, if I resize the window, you can see the kind of animation gets cropped off. So you can add in a window listener, listens to resize, and on that calls this function, which just changes the aspect ratio of the camera based on now the updated width and height of the window. So this essentially is equivalent of kind of the hello world of Three.js, this stuff. Okay. So just going back. So just to finish up and just kind of summarize things, I suppose kind of a take-home points is basically, if you're going to remember anything, WebGL, it's kind of a low-level API. You know, you'd want to be crazy to go programming it unless you're actually being paid by a game engine company to do something, to do some work with it. Three.js is the high-level API, and it makes programming it relatively easy. I suppose what's in the future in the next few months or in the next few years, the actual tooling, like tools like Unity, kind of make it, you know, there's a kind of a break point where you might be better off using one of those tools that rather than Three.js. They're quite professional, and you get things like physics engines and proper animation tools and things like that. And I suppose the exciting development about this is that on mobile, there'll be a new mechanism to create apps for iOS 8 independent of the Apple App Store. And funnily enough, on Android, it still hasn't kind of been resolved. There's kind of still a lack of clarity. You can, if the user has actually installed Chrome, then you can use WebGL. But if they have kind of the stock Android browser on it, they're not going to see it. And disappointingly, in KitKat, the latest version, they changed the WebView to be based on Chrome, and they actually left WebGL out of it, which is strange. And on the desktop, there's excellent support on the desktop for doing WebGL, and there's interesting possibilities when it's going to be combined with WebViewer and head-mounted displays, and when you just connect that up to a head-mounted display to a browser, and someone can experience the 3D world that you're generating on the server. So I I'll put these slides up. I just have some references to the sites that I've been talking about. If you wanted to kind of learn it this is a good site which has some basic examples and goes all the way through using Three.js. And these are 2 books that I'd recommend for learning it from Pact Publishing, Learning Three.js, the JavaScript 3D library for WebGL, and Three.js Essentials. So, thank you.